Hi, in this video I'm going to discuss Mathematics M3 paper, June 2021. All the questions will be discussed in this video. Okay, so this is the first question in this paper. This diagram is given. A hollow toy is formed. Hollow, so nothing inside. It's like only the shell outside. A hollow toy is formed by joining a uniform right circular conical shell C. This is conical shell C. This is conical shell C with a radius of 4a. So its radius is 4a. That's marked here. To form a conical cell with radius 4a and a height 3a. Height is 3a. To a uniform hemispherical shell H. So this is a uniform hemispherical shell H with a radius 4a. So this is the shell, hemispherical shell, which has radius 4a. The mass per unit area of C, this mass per unit area of C is lambda. That is like a mass per unit area is lambda. And the mass per unit area of H is K lambda, where K is constant. Given that the center of mass of the toy, that means for the system, center of mass of this system is a distance of 4a from the vertex, 4a from the vertex of the chord, and find the value of K. So the center of mass of this toy is at a distance of 4a from this edge. I can name that edge A. Right, okay, so here this question is based on center of mass. You must know the meaning of center of mass before approaching this one. We know the center of mass of different shapes given in your booklet, and we'll use that also. But basic idea, what is the meaning of center of mass of system of particles or system of objects? Say for example, we need to measure the distances of, when there are system of particles, we need to measure the distance of center of mass of each and every particle. So we need a reference point. Normally we can take the same point. Normally we take it as the same point. So for example, from this point O, there are many different particles. Its mass is m1 at a distance of x1. There is a particle m2 at a distance of x2. Like that, there are many particles. There is a particle mn. Its distance is xn. So there are different point particles. Okay, doesn't matter. We can take it as point particles. So what is the center of mass of the system of these particles? How the center of mass is defined mathematically? The center of mass of the system of particles x bar is given by x bar equal m1 x1 plus m2 x2 plus up to mn xn over the total mass m1 plus m2 plus up to mn. That's the definition. So in a notation we can say summation, that is sigma mi xi, I is equal to 1 to n divided by sigma mi, that's the total mass, I equal 1 to n. That is the definition of center of mass of the system of particles. But same thing we can use for center of mass of system of objects when we know the exact point of the center of mass of each and every object. It could be different objects. So there's an object, big object, but its center of mass is at this point. So its distance from O is x1. There's another object. Its center of mass is at this point. So the distance of the center of mass of this object is x2 from O, like that. If we know the system of objects, we must know the center of mass of each and every object from a point. Then from the same point O, we can find the center of mass of the system of all the objects together, that is defined by this equation. Okay, so we are going to use the same principle in this question. Nothing, same principle, x bar equal sigma mi xi, where mi is the mass of each and every particle or each and every object and its center of mass from a point. This is the total mass of the system of particles or total mass of the system of object. This is the center of mass of the system of objects. You can cross multiply, and also you can write this as x bar times sigma mi, I is equal to 1 to n equal sigma mi xi. That is I equal 1 to n. This way also we can write by cross multiplying this. So I want to use this one here. I am going to use this one in this calculation. Nothing. So you know, in mathematics, the method is the same. Every year, whenever there's a question related to finding the volume by a graph, I think there's a question again in this paper I discussed already. June 2020, January 2021 paper. Same way here also, I think question 3 again they are giving a graph, and same approach, we need to find the volume and the center of mass. So whenever you get a question related to finding the center of mass, you need to approach the same method. That's all. Okay, so so in this question also we are going to use the same approach, same method. So that means first we must know the mass of the conical shell, that we can find it. We should find the surface area of the conical shell, that is given by 1/3 pi r l. L is the length of the slope. We can find them, no problem. So we should be able to find the mass of the conical shell, the hollow conical shell, that is 1/3 of pi r l, and the density which is given as k. Yeah. Then we must know the center of mass of the conical shell. We know normally in your data sheet it's given from O. What's the distance? That is from O. That is 1/3 of the height. So from A we can find it. If you know the center of mass of the conical shell from O, we can find it from A. If we know the total height, from here the center of mass is at 1/3 of the 3A means from here we can find it, not a problem, right? Same way we should find the mass of the hemispherical shell. Okay, so we know the surface area 4 pi r squared for a sphere, half of the sphere 4 pi r squared over by 2, then multiply by the given mass per unit area. You will find the mass of the hemisphere shell. Then we know the center of mass of hemisphere shell is at a distance of r by 2 from the base. They are telling it, the booklet, r by 2, the half of the radius is the position of the center of mass from this base. So we can find from A what would be the distance of the center of mass of the hemisphere shell, right? Okay. Now the system, the whole object has center of mass at a distance of 4A from A they have given. So we know the total mass of the center of total mass of the system, we can find it. So total mass, so the approach here what I am going to do is total mass of the object, if I say m times x bar, m times x bar, or x bar into m. X bar is the distance of the center of mass of this whole system into the mass of the whole object. We need to find it. We can find that an issue is equal to, I am measuring everything from A, so all the distance are measured from A. Okay, so this I am planning the idea, giving you the idea, is equal to center of mass of the conical shell from A. I need to find it, so I can name that XA. XA from A for the conical shell, XA into, that is the shell, or XC, I can, it's given as C. So XC is the distance of the center of mass from A into MC, mass of the conical shell C, plus distance of the mass of the hemisphere shell, that is XH into mass H. That's all. If I solve it from this is given, everything are given, only thing K we need to find it, substitute, you will find the value of K. Okay, that's the idea. Everywhere, whenever we get a question related to center of mass, this is the approach we are going to follow it. Okay, sigma mi xi equal to sigma mi into x bar. X bar is the center of mass of the system. Okay, here I am using the definition. X bar is equal to sigma mi xi over sigma mi, that is m. Sigma mi is m. Okay, so we'll find these one by one. So I need to find the surface area of the conical shell. So surface area of the conical shell is given by 1/3 pi r. Sorry, conical area is given as pi rl. So this is the L, the length of the slope. I need to find it. So it's not a big issue. So we'll consider right angle triangle here. This is C. So we'll consider this right angle triangle. So I need to find the L. So this is 3a, this is 3a, this is 4a. So L squared is equal to 3a squared plus 4a squared, Pythagoras theorem. So from that L we can find it, that is equal to 5a. So the surface area of the C, that is equal to pi RL. So pi, the radius is 4a into L, 5a. So you will get the area. So from that we can find the mass of the conical shell. So mass of the shell, conical shell, equal this into the mass per unit area, that is given as K. So that's going to lambda, sorry, not K, lambda. So that's going to be pi times 20a squared into lambda. Okay, that's the mass of the conical shell. So that is, I can say MC, that is MC equal 20 pi a squared lambda. Okay, that's MC. Okay, so I need to find the mass of the hemisphere, hemispherical shell. I need to find it. So mass of the surface area of this one, you know, for a sphere 4 pi r squared, half of it. So mass of hemispherical shell is named H, that is equal to surface area 4 pi r squared, for a sphere, that is 4 pi into 4a squared by 2, because hemisphere divided by 2, 4 pi 4a all in squared, into the mass per unit area is given as k lambda. So solve it. That will be equal to you will get it 32 pi k lambda a squared, pi a squared k lambda, right? That's the mass of the hemispherical shell. So mass of the toy, so this is called as a toy, I think, yeah, a hollow toy. Yeah, mass of the toy, that is capital M, mass of the toy, I named as capital M, that is equal to, at both, that is MC plus MH. That is MC plus MH, 20 pi a squared lambda plus 32 pi a squared k lambda. That is the mass of the toy. Okay, so now I need to find the distances of the center of mass and each and everything. So that the data book that says the center of mass of the conical shell is at 1/3 of the height from the base. So 1/3 of the height from the base is the center of mass. So from A, what is the distance of center of mass? So distance of the center of mass of the conical shell from A, that is 3A minus 1/3 of A. So that I named it as XC. So XC, distance of the center of mass from A. So I am measuring from center of mass as from A. From A I am going to measure, that is XC, the center of mass of the conical shell from A. This is 3A. From the base 1/3 of the height. So from A is going to be 3A minus 1/3 of height. Height is 3A. So you will get 2A. Right, center of mass of the hemispherical shell given in the data book, that is from the base half of the radius. So from the base half of the radius. So from A, that will be at 3A plus half of the radius. Radius is 4A. So 3A plus half of 4A. And that is the distance. So that is XH. That is XH from A. That's going to be 3A plus half of the radius 4A. That will be 5A. And the center mass of the toy is given from A, that is at uh, 4A. So x bar, that is at 4A from A. Right, now we are going to apply this equation, x bar m. So x bar m is equal to xc mc plus x h mh. That's a sigma mi x, so x bar into m, that is what is sigma mi xi. The same principle I am using it. So x bar, we know that 4a times m is given 20 pi a squared lambda plus 32 pi a squared k lambda equal to xc we know that 2a, I'm writing here 2a into mc we know that mc, yeah, 20 pi a squared lambda plus xh is 5a into mh is 32 pi a squared k lambda. Okay, right, so this is the equation. You will get it, solve it, carefully solve it, because there are a lot of numbers. All the pi will get cancelled. Here a cube, here a squared, here a cube, here a squared. So you can divide the whole equation by a squared. Then you can divide the whole equation by lambda. Yeah. So like that, solve carefully step by step. You will end up with 160k minus 128k or you can, I'll write the final answer. Yeah, it's okay. Is equal to 80 minus 40, that is 40. So finally you will end up with 32k is equal to 40. So k will be equal to 5 by 4 or 1.25. That's the answer, you will get it. Only the problem here solving, sometimes you might make careless mistake, but understand the principle, that is sigma mi xi equal sigma mi xi over sigma mi is the x bar, that is the center of mass of the system of objects. Okay, so question number 2, this diagram is given. Figure 2 shows fairground ride that consists of a chair of mass m. This is the chair of mass m. Attached to one end of a rigid arm of length 5a by 4. The other end of the arm is freely hinged to a rim. This is the rim. Hinged to the rim of a thin horizontal circular disc of radius a. So this is a horizontal circular disc that has radius a. The disc rotates with a constant angular speed omega. So the disc is rotating at constant angular speed. Omega means the chair also will have the same angular speed. You know what's meaning of angular speed? Rate of change of central angle. So if this point horizontally rotates through angle theta, then the mass of the chair C also will rotate to the same angle theta during the same time. So rate of change of angle will be same for any point of the disc and the attached the chair or whatever it is they are saying it as a chair. Yes, its change in central angle will be the same. Okay, change in central angle means first you should be able to identify the center of the circular path. Now this is called disc, is it? It's called circular disc of radius n. So this is a disc. So when the disk rotates at angular speed omega, the chair which is attached to the disk by a rigid rigid arm, yeah. So this is going to move in a circular path. So we should be able to identify the center of the circular path. For this M, the center of the circular path will be somewhere here. So it's going to move on a circular path. Forget about the upper part. So this is going to move on a circular path with the same angle theta when it rotates at the same angular speed. The center will be somewhere here. So the circular path of this one will be something like this. Will be something like this. So the circular path of the chair will be O, not this point. This is the center of the circular path. So what could be the radius? We can find the radius of the circular path of the chair. We must be able to find it. So this is the radius of the circular path that we can calculate it. A plus this length in the right angle triangle, we can find it, this length 5a by 4 sine theta in this right angle triangle. This length is 5a by 4 into sine theta. So this is going to be a plus 5a by 4 sine theta. So in very important circular motion, when you are doing any questions, you must be able to identify the center of the circular path. Careful. So these students might think this is the center of the circular path, or maybe this is the center. No, this is the center of the circular path of the chair. Careful. Identify the center of the circular path of the object you consider. The object we consider is the chair. Its center is here, not any other points. Then we must be able to find the radius of the circular path. Yeah, we can use geometry, little bit of trigonometry. We can find the radius. Yes. Third, you must be able to identify all the forces acting on the object. Here the C is the object that performs the circular motion. You should be able to identify all the forces, actual forces acting on it. I will draw and show the forces acting on it. Then the centripetal force. What is the centripetal force? Centripetal force means resultant force acting on the object towards the center. So we should be able to identify all the forces acting on it, the actual forces. You can draw a force diagram we call free body force diagram. Then from that free body force diagram, you should be able to resolve all the forces towards O. That will be the centripetal force. Centripetal force is equal to mr omega squared or mv squared OR. You must be able to do. If you do that, you can answer any other questions, right? Related to circular motion. Identify the center of the circular path. Identify the actual forces acting on the object. Then you should be able to find the centripetal force, that is the resultant force towards the center of the circular path. Then beyond it, solve the equations. There could be a little bit of mathematics. Otherwise, by using them, you can find it. Okay. Also better know, when it moves on a circular path, due to centrifugal effect, the object will have the intention of moving away from the center. That's the reason when it rotates in circle. Now, when the disc stops, the ring will come vertically like this. When the disc stops rotation, the chair will come to along this vertical dotted line. But when it moves, why the chair is moving this way? The reason, you can hang a string attached to a small disc and rotate it. You will see the string will move away, because that is called centrifugal effect. When an object moves on a circular path, it has intention of moving away from the center. That also you must know that. Okay, so the question is, find the tension in the arm in terms of M and G. So I need to find the tension in arms. Okay. Nothing. So we'll find the radius first. Now I have told everything, you must follow that. So the radius of the circular path need to be R. So R is equal to this length, that is A, same A plus 5A by, when you consider this right angle triangle, 5A by 4 sine theta. So that is A plus 5A by 4 sine theta. That is the radius. But sine theta given in the question, tan theta is given in the question, tan theta given in the question, tan theta is equal to 5a by 4. Okay, so tan theta equal 5a by 4. Let it be a plus r sine theta. 5a by 4 sine theta. So we can find that tan theta given means, you can imagine of a right like a triangle. Right angle triangle. To find the other quantities, this is theta. Tan theta means 5a by 4. So that means, 5 by 4, I made a mistake. Tan theta 5 by 4, sorry. I wrote something else, sorry. 3 by 4. I wrote something else. 3 by 4, sorry. Tan theta 3 by 4, so that is, I don't know, I read the length, sorry. Tan theta 3 by 4, so tan theta 3 by 4 means opposite over adjacent. So this is Pythagoras theorem, use 3 squared plus 4 squared 25, square root of that is 5. So sin theta, you know sin theta equal 3 by 5. So from that we can find the R is equal to A plus 5A by 4 sin theta 3 by 4. So you will get 3 by 5, so 3 by 5. So solve it, you will get the answer. How much is it? This will be, so that will be 7A by 4. That is the radius. Okay, we found the radius, 7A by 4. Okay, so now we need to think about the forces acting on the particle, the chair C. What are the forces acting on it? So the weight is acting downwards, mg. And the tension of the cable, that's the question. Tension is acting this direction, that is T. This angle is theta. So center is O, so center is somewhere here. Okay, so the chair is moving on a horizontal circle. So if it is moving on a horizontal circle, like on Newton's first law, there is no resultant force in vertical direction. Because if there is a resultant force in vertical direction, the object will accelerate in that direction. So in vertical direction, there is no resultant force. So vertically, and I consider the resultant force must be equal to 0 according to Newton's first law, because it's moving on a horizontal circle. So that means T cos theta minus mg must be equal to 0. These are the two actual forces acting on it. So T cos theta equal mg. Okay, so then centripetal force, the resultant force towards the center of the circular path is the centripetal force. So resultant force towards the center is O, that is F equal the resultant force towards the center, that is going to be T sin theta. T sin theta. Mg is a vertical force that has no horizontal component. You can't resolve a vertical force in the horizontal direction. The component equal to 0. T sin theta equal mr omega squared. So that means T sin theta is equal to mr omega squared. So we'll substitute them later. M is not given, but R I can substitute here. 7A by 4 omega squared. So angular speed is given omega in this question. Constant angular speed, I took it as omega. Yeah, it's given omega, right? Okay, so this is the second equation. So from this, the question is they asked to find the T. Is it? They asked to find the T. I can find the tension from the first equation. I don't need the second equation. From here I can find the tension. T cos theta equal mg. So T is equal to mg over cos theta. That's easy. Don't need to go beyond that. I started doing the second part also. Mg over cos theta. That is mg over cos theta. We know that cos theta is equal to 4 over 5. That is 5 mg over 4. That is the tension. First part they asked to find the tension. Yes. So that's enough for the first part. Yeah. Okay, second part they asked to find the omega in terms of A and G. So that's nothing. For that we'll use the centripetal force. First part they asked to find the tension. So second part we know the resultant force towards the center, that is T sin theta is the resultant force towards the center is equal to mr omega square. We'll substitute T from the first part, R from here. We'll find the omega square. Okay, T is equal to 5 mg over 4 times sin theta. We know that sin theta is equal to 3 by 4 equal to m. Anyway, this m will get cancelled. R is equal to 7a by 4. 7a by 4, yes, into omega square. Okay, solve it and find the omega. So solve it, will get omega squared equal to, when you solve you get omega squared equal to 3g over 7a. So So omega is the question square root of 3g over 7a. Okay, so remember that during circular motion, what points you should take care of it. Find the center of the circular path. You should identify the center of the circular path. Find the actual forces acting on the object, and you should be able to resolve the actual forces towards the center. That will be the centripetal force. That's enough. Beyond it, maybe geometry like this, simple geometry you need to use, or someday you need to solve. That depends on the type of questions. But the principle is the same in all circular motions in any grade. Sin theta 3 by 5, not 3 by 4. Chaos mistakes are there. 3 by 5 sin theta. Yeah, 3 by 5 sin theta. So 5 get cancelled. 3 mg by 4, this 4 get cancelled. Solve it, you'll get the answer. Okay, question number 3. Again, that is based on finding the volume and center of mass. Same principle. But here the shape of the object is not given. It's of shape of the object. An equation of a graph is given, and they are saying it's rotated about x-axis. So we find the equation of the graph is given. The finite region enclosed by the curve with this equation and the line x equals 0 and y equals 0. X equals 0 is the y-axis, y equals 0 is the x-axis. So we'll draw the first graph, sketch the graph. So we know that when x equals 0, y equal to 3, then y equal 0, x will be 9. So the shape of the graph will be something like this. It's going to cut the x-axis at 9. This will be 3. Okay, so they are saying this graph rotated through 2 pi radians about x-axis. So they are going to rotate this about x-axis. About x-axis they are going to rotate. So when they rotate about x-axis, we'll get a shape like this. This is the shape we are going to get. We need to find the volume, first part, find the volume of the S. They call the name of this solid object after it's rotated. So it's going to be like a circle here. So I'll draw this diagram again. Rather than using a Cartesian coordinate, I'll draw it the shape like this. It's going to be. So it's going to be a circular path, something like this. Okay, so this length is 9 and the radius of this circular, this is the center, so radius is going to be 3. Okay, so they asked to find the volume, so they call this shape as S. The name of this solid object is S. They asked to find the volume of it. So same method, whenever you are given a graph and it is rotated through 2 pi radians, and when they ask to find the volume of the shape, the idea here, we need to find the volume means first we'll imagine a known shape of tiny 3-dimensional figure inside the given object, and we assume we can fill this given S or given object by many such tiny objects. So for this, the tiny 3-dimensional solid is a disc shape. So we can imagine a disc something like this. Something like this. So I can draw this again here. If I draw it something like this is the disc I want to imagine. So its radius is, if I say y, the radius is y. So the radius, I'm going to take this as a radius y. We know the y from the distance of the disc I imagine x. We can relate the radius y and the distance of the disc that imagine x by this equation. Okay, so we can find the volume of this disk. You know, volume of a disk is pi r squared h. Here h is dx. The thickness is dx. We consider the thickness dx. Imagine the volume of the disk, something like this shape. Something like this. The thickness is dx. The radius is y. So the volume of it is pi r squared, that is y squared dx. Okay, that's the volume of it. Okay, so we imagine we are going to fill this S. S is the name of the object or the solid three-dimensional object. We are going to fill this by many different disks from this edge to this edge. If we know volume of each and every disk, if we add all those volumes, we will get the whole volume. So I can say the delta V, the volume of the smaller disk, what I imagine inside. The same method we do everywhere when we get a question like this. So that is delta V, the volume of the small object, what I imagine. Delta V, this is the first part I think. The delta V is equal to pi y squared dx. Pi y squared dx. Okay, so pi y squared dx, but y is the radius, dx is the thickness, but or the height of it. So y, we know the relationship, so that is pi y squared means 3 minus root x or the squared dx. We can solve this one. We expand that. When we expand, we will get pi into 9 minus 9 plus x minus 6 root x dx. That is the volume of the small disk that I imagine inside the S. Okay, so the total volume is, I imagine if I keep such many different disks, those are different distances x1, x2, x3, x4. If I arrange them inside and if I know the volume of each and every, and if I sum it, if I add those volumes, I will get the volume of the S. So that is the volume of the S is, volume of the S is V, that is equal to sigma delta V. So that means sigma pi 9 plus x minus 6 root x dx. So now summation with a variable x means we know that is integration. From where to where should I imagine the disk? From x equals 0 to x equals 9. X equals 0, that's the left edge, to x equals 9. If I imagine like tiny many different disks, and if I add the volume of all those disks, I'll get the final volume. So that's a sigma with variable means it's going to be an integration. So that's going to be integral of pi 9 plus x minus 6 root x dx. So the x going to be from where to where? From 0 to 9. That's all. Now we'll now mechanics over. Now pure maths, pure mathematics, solve it in a normal way. So if you integrate it, that means I can take the pi out, that is 9x plus x squared by 2 minus 6. This is x to the power half. X to the power half, if you integrate it, you know that x to the power half integral dx, you know, plus 1, that is 3 by 2. So 6 into x to the power 3 by 2 over 3 by 2. The limits are from 0 to 9. Okay, solve it. Substitute pi 9 into 9, 81. We can substitute the values of 9 first, then 0, nothing wrong. Or we can 1 by 1 substitute, yes, a ratio. We can put partially, okay, if you have confusion, like step by step, 0 to 9 plus 0 to 9. Yeah, basically right. Minus 6 x 3 by 2 over 3 by 2 also I can take it out, no problem, 0 to 9. Okay, so solve them. So when you solve, you will get finally pi into 81 plus 81 by 2 minus 4 into 27. Solve it, check it. Okay, that's right. So then finally the volume will be equal to, I'll write it here. The volume will be equal to 27 pi over 2. Right, so that's the final answer. So the idea is summing, adding different volumes of identical objects. Normally we take this here. Okay, B part of question number 3. Find the x coordinate of the center of mass of S. That means we need to find the center of mass of this S from the point O, from the origin. Find the x coordinate of center of mass means from O what will be the center of mass distance. Okay, again I'm going to use the same principle as what I used in this paper first question. I think sigma mi xi over sigma mi is x bar, same principle. So we imagine the center of mass of this small disk at a distance x from this O. So the distance of the center of mass, because this is a disk, it's uniform disk, tiny disk, its center of mass will be at the center. So the distance of the center of mass of this disk from O is x. So mi xi, so we need to find the mass of it. So already we know the volume of it. So that is mi, that is equal to volume of this one, that is pi y squared dx into rho. I'll put it as rho as a density. Anyway, rho will get cancelled. Sometimes your marks team, they don't use rho, they take it as 1 unit. Doesn't matter, it will get cancelled. So we know that total mass of this S, we know the volume. So that is m, the total mass of it is volume of the whole S into density. Volume we just now found it. That is 27 pi by 2. We found it just now. Is it? Yes, 27 by 2 pi into rho. That's the mass of the whole S. Right? The center of mass of it, we need to find it. X bar, we need to find it, question mark. But center of mass, this one, this particular disk is at a distance x. So sigma x bar into the total mass of the system is equal to sigma mi xi. That's the basic principle. I used it in the first question also. Everywhere when you get a question related to center of mass, this is the approach. Okay, so x bar into m, that is 27 by 2 pi rho is equal to sigma mi xi, sigma mi, that is pi y squared, again pi y squared is coming, so that is y squared means you know that pi, I write that pi y squared dx rho into xi, the distance of the center of mass of this tiny disk from O, it is at distance x. Right, so solve that, keep this left side same, that is going to sigma pi, instead of y squared we need to substitute that equation 3 minus root x, all things squared, x, I wrote it here, dx, rho, but this row and this row will get cancelled, so I'll cancel that row, anyway they will get cancelled. Okay, so we need to summation, but whenever there's a summation with a variable, you know that's going to be the integration 0 to 9, the limits, because x is going to be 0 to 9 to get the whole volume of it. Pi, again the same equation with x what we got earlier, you have to get multiply by x, so that's going to be 9x, 3 squared is 9 into x, 9x plus x squared minus 6x to the power 3 by 2. Earlier we got 6 x square root of x, now square root of x into x x to the power 3 by 2 dx. Okay, solve it. So normal simple integration. So solve it. When you solve, you will get that is I'll write it here. When you solve, you will get x bar into 27 pi by 2 is equal to, that's on the left side. Right side you will get it. So both sides, this pi and this pi also will get cancelled, doesn't matter, we'll write it. So okay, pi within bracket, it's going to be 9x squared by 2. When you integrate 9x squared by 2 plus x cubed by 3, x cubed by 3 plus minus 6x to the power 5 by 2, 3 by 2 plus 1, 5 by 2, 5 by 2 over 5 by 2, the limits from 0 to 9. Okay, you know how to solve that. Substitute for 9 first, then 0 first. Or you can do separately one by one if you have confusion, substituting everything. So pi and pi get cancelled. So that is 27 by 2 x bar is equal to, you can do separate if you have confusion, x squared, the limits from 0 to 9 plus 1/3 x cube 0 to 9 minus 12 by 5, 2 goes up, 12 by 5, x to the power 5 by 2, 0 to 9. Okay, now you can solve that. It's simple. So finally, when you solve, you will get the right hand side answer 24.3. 24.3 you will get it. So x bar 24.3 divided by 27 by 2, you will get it 1.8. That's the final answer. Distance of the center of mass of S from O, the origin, is 1.8 units. Okay, question number 4. It's circular motion. This diagram is given. It's a vertical circular motion. A circus performer of mass M, she is attached to one end of a cable of length L. The other end of the cable is attached to point O. Initially, she is held at rest. So, she is at rest at this point. We can mark those things. She is at rest here. U equals 0. The mass is M. She is at rest at that position. With a cable taut and at an angle 30 degree below the horizontal. So, she is at point A initially, the position that is A, initial position. That makes an angle 30 degree with horizontal. The circus performer is released from A and she moves on a vertical circular path with center O. The circus performer is modeled as a particle and the cable is modeled as light and inextensible. Find in terms of M and G the tension in the cable at the instant immediately after the circus performer is released. Okay, so again circular motion, you must know, must be able to identify the center of the circular path. So the particle, we assume the circus performer as a particle, so it's going to follow a vertical circular motion. Its center is O, the radius is L. Then we should be able to identify the actual forces acting on the particle. So the circus performer M, how many forces acting, the weight is acting downwards, mg. Then the tension will act towards O, tension. So the angle with horizontal, it makes an angle 30 degree, means with vertical it will be 60 degree, is it? With the horizontal it makes 30 degree, means with vertical that's going to be 60 degree. Okay, so we need to find the tension of the cable in terms of these quantities. So she was released from rest. So at the moment she is released, her speed is 0. The speed is 0. So we know at the moment she is starting from rest on a circular path, but at that moment she is her speed is 0. We know the resultant force towards the center of the circular path is defined as centripetal force, which is given as mv squared over r, or mr omega squared. So the center of the circular path is O, so that along that line tension is acting. We need to find the resultant force acting on the particle towards the center of the circular path, that is the centripetal force. So centripetal force towards the center of the circular path, F is equal to T minus mg cos 6t. That is equal to mv squared over r is L. But anyway, the speed is 0 at that moment. They are saying when she is released, V equals 0. At the moment she is released, V equals 0. So T minus mg cos 6t equals 0. So T is equal to mg cos 6t. So the tension at the moment she is released is mg by 2. At the moment she is released, the tension is mg by 2. That's the answer for the first part. Okay, second part, that is a little bit more mathematical. Show that during the motion following her release, the greatest tension in the cable is 4 times the least tension in the cable. So we should be able to identify the greatest tension, where will it act, how much will it be. Least tension, where will it act, how much will it be. Then we should find the ratio of greatest tension to lowest tension, and we should get it 4. Okay, for that we'll take a situation like this. After she is released from rest, at an instant when she is somewhere here, when the particle is here, this has come to this position, the length is L. At that moment the speed is V. We don't know how much is the V. Okay, we know we need to find the least tension and the position, most tension or the highest tension and the position, and we need to find the relationship between least tension and the greatest tension. Okay, we'll see. Initially that makes an angle 60 degree with horizontal, 30 degree with horizontal, means with vertical it makes 60 degree. So this is 60 degree. This is 60 degree. During the motion, at an instant, when it comes to this position, we'll take the particle, the particle or the person making an angle theta with vertical. Okay, we need to find the speed, because you know tension, whatever the equation we get, tension T equal mv squared over r, there will be centripetal force when we get, there will be speed. So we need to find the speed at this position. Okay, we'll think about the forces acting on the particle at this position. What are the forces acting on the particle? If we think like that, draw the particle. The tension will be along the towards the center, that is T. The weight will act vertically down. The tension makes an angle theta with vertical. So this is theta. Okay, so the speed is V at that moment. We can use energy equation. We assume there is no drag force, no energy loss. So when the acrobat or whatever, the circus performer moves from A to this position, we'll name this position B. When it moves from A to B, we can use the energy equation because there is no change or loss of energy. So loss in Gp equal gain in K, loss in Gp. So through what height she is falling, we need to find it. So this position is A. So the height through which she is falling when she moves from A to B is this height. We need to find this height H. This is the height we need to find. This height H, we need to find it. That's the height through which she is moving down when move from A to B. So how can we find it? This length is L. So this H is equal to this height. That is, when we consider this right angle triangle, OB, we'll name this point N. When we consider right angle triangle, OBN, this length ON is equal to L cos theta. When we consider this right angle triangle OA, this point NP, OAP, this height is L cos 60. So H is equal to L cos L cos theta minus L cos 60. So H is equal to L cos, this, consider this right angle triangle. In this right angle triangle, L cos theta minus, in this right angle triangle, L cos 60. Initially it makes an angle 60 with vertical, that is L cos 60. So that's going to be cos 60 half, so that we can write L into cos theta minus L by 2. Okay, we'll continue. Loss in GPA equal gain in K. We consider the motion from A to B. When we consider the motion from A to B, loss in GP equal gain in K. Loss in GP mgh. Gain in K half mv squared minus half mu squared, but u is 0. Okay, all the m will get cancelled. So g into, instead of h we can put L cos theta minus half. Is it GL? I took it out, so cos theta minus half is equal to half v squared minus 0. U was at rest. Initially she was at rest, so half v squared. So v squared is equal to 2GL cos theta minus half. Okay, so that's V at that point. Now we need to find the tension, because the question is related to maximum tension and minimum tension. So we'll take general equation when it makes an angle theta. Then we'll find out at what theta tension becomes maximum, at which theta tension becomes minimum. So the tension at point B, so at point B we are going to use the resultant force towards the center of the circular path is called centripetal force. That is T minus mg cos theta equal mv squared over r is L. Okay, so that is m over L v squared, substitute 2g cos theta minus, multiply inside 2g, I think L, I'm missing 2gl, no, so that's a mistake, 2gl. Yeah, so 2gl cos theta, 2gl cos theta minus gl, half into 2gl. Okay, so you can solve it further. You will get it, when you multiply that, L and L get cancelled. So that is 2mg, L get cancelled, cos theta minus mg. So that is T minus mg cos theta. So T is going to be minus mg cos, when you go to right, 3mg cos theta minus mg. Okay, that's the final expression. We are getting 40. Now we know that T is going to be a variable depending on only on theta. So at different theta, the tension will be different. We will find the maximum T and the minimum T. Okay, so where will be the maximum T occur? So to get maximum T, this is constant mg is constant, 3mg constant, only theta is the variable. So we can get the maximum T when the cos theta is maximum. When the cos theta maximum is 1. That occurs when theta equals 0. Theta equals 0 means when the theta, this theta is measured with vertical. Theta 0 means when she comes exactly vertical. When the cable becomes exactly vertical, the cable will have the maximum tension. So T max occurs when theta equals 0. So we can write that here. T max occurs when cos theta equal 1, that is theta equal 0. So they will find the T max. How much? T max is equal to substitute 1, 3mg cos theta 1 into 1 minus mg, that is 2mg, that is the maximum tension when theta equals 0, that is exactly vertically down. T minimum occurs when we know that when theta increases, cos theta will decrease. You know the graphs, theta, cos theta graph. When the theta increases, cos value will decrease. But theta can increase up to 300, this theta can go up to, after 0, it can go up to any amount. But in this question, the theta cannot go beyond 60. They said it was released from 30 degree. So that means with the vertical, it can't go beyond 60 degrees. So the maximum value of theta is 60 degree. That time you will get the minimum value. That's the value we got initially when in the first part. So T minimum occurs when cos theta is equal to 60 degree. That we already found it in the first part. So T minimum occurs when theta equals 60 because it released from 60 degree vertical or horizontal 30. It can't go beyond it according to the conservation of energy, according to law of conservation of energy. When it comes to that position here also, it will come to 0. The kinetic energy will become 0. So it can't go beyond it. So that time the minimum tension occurs. So that T minimum is equal to when theta 60, if you want you can substitute, but you don't need to do, we already found it in the first part, that is mg by 2. Okay, so T max over T minimum equal to mg over mg by 2 equal to, that's what they asked to show. Okay, question number 5. A particle P of mass 0.5 kilogram moves on the x-axis under the action of a single force at time t equal t seconds, which is greater than 0. OP equal x meters and the range of x is greater than 0, less than pi by 2. The force has magnitude of sine 2x Newton and is directed towards the origin O. P is moving in the positive x direction with a speed v. At time t equals 0, P passes through the origin with a speed 2 meter per second. Show that v equal to cos x. Okay, just nothing, Newton's second law. We'll solve it. Simply we'll get the equation when we integrate it. Okay, we'll put it on a diagram, this one. So this is the O, the origin. Particle is somewhere here. So it was at here when t equals 0. The particle was moving at 2 meter per second at this position. They are saying it. So it's moving in the x direction. So it's moving towards this direction. So at later at time t equal t, the variable, time t equal t, it is at a distance x from the origin. And it has a speed away from the origin at speed x, away from the origin in the positive x direction, that is v. And the force acting on it, so this is the particle P, force is acting on the particle towards origin. That's what they are saying. The force has a magnitude sine 2xn towards the origin, so that is F equal sine 2xn 2x Newton. So this is the particle P at time t equal t, right? I don't need to put the P. Okay, so I need to show that the V is equal to 2 cos x. Okay, nothing. So Newton's second law. So something related to force. That force is a variable, not a constant. So whenever we get an equation where force is depending on distance or function, we have to integrate it. In physics, that will be a constant. If we call MA, we can directly use it. But here we can't use it because we have to integrate. X is the force is a function of x. Right, anyway, but not, the basic principle is the same. So we use the F equal MA or mx double dot along the direction of increasing x. So x is increasing distance. So this is taken as positive from origin along the direction of positive x, that is the increasing x. We take it as positive. Okay, F equal mx double dot. So F is towards the equilibrium position. So we need to put minus sine 2x minus sine 2x equal m x double dot. You know that dv over dt. dv over dt is the acceleration that could be written as dv over dx into dx over dt. dx over dt is v, you know that. So that we can write v dv over dx. Okay. So we need to integrate it. So that means minus sign we can keep it on left. So integral of sine 2x equal to m integral of v dv. Okay, so what are the limits? When x equals 0, speed equal to. So when x equals 0, speed equal to. When x equal, the question is when x equal, yes, it's going to be a variable. X equal x. That's the thing, x equal x, because they asked to show the speed v in terms of x. So it's a variable. X equal x, the speed equal v, we have to get the expression, right? We'll try to solve it now. So that dx is missing, sine 2x dx. Okay, so when we integrate sine x, it becomes minus cos x. Sine 2x means minus cos x by 2, is it? So when we integrate it, it's going to be, this minus is there, minus cos 2x by 2. The limit will be 0 to x. That is equal to mv squared by 2, 0 to v. So minus minus will get cancelled. The limit will be x. Cos 0 is 1. So that's going to be cos 2x. I can take the half out. Okay, we'll put cos 2x by 2 minus half. Is it ever right? Cos 2x half is equal to this m by 2, but these two all are going to get cancelled. M by 2 v square. So all these two will get cancelled. So we'll get cos 2x minus 1 equal m v square. We know the mass. Mass of the particle is given. It has 0.5 kilogram. We'll substitute the mass here. So we'll continue here. M is given 0.5 kilograms. So m is 0.5. Yes, 0.5 kilograms. So cos 2x minus 1 equals 0.5 v square. So 0.5 means half. So multiply the whole equation by half or whatever it is, it's not an issue. So that's going to be 2 cos 2x minus 1 equal v square. We know that cos 2x, the question it says show that v equal cos x. So cos 2x we can write it in terms of cos x. So that is 2 times cos 2x is 2 cos squared x minus 1 minus 1. This minus 1 I wrote it. So 2 cos 2x, sorry, minus 1 is equal to v squared. Cos 2x is equal to 2 cos squared x minus 1. So that's going to be, I think, yeah, it's 2, there will be minus 1 half, there will be minus 2, yeah. Yes. And okay, after there, this 2 to 4, I put 0, sorry, 2 here, 2 to 4. So that will be m by 2 v squared minus m by 2, that is, that's going to be 4. Yeah, sorry, there's a calculus mistake. So mv squared minus 4. Yes, mv squared minus 4. This is 2, but I put 0 here, calculus. So m by 2 v squared minus 4. Yeah, that's now correct. So it's going to be okay, so cos 2x minus 1 is equal to 0.5 v squared minus 4. Yeah, that was the mistake earlier, 0. Okay, so that's going to be half means 2 cos 2x minus 2 equal v squared minus 4. So v squared is equal to, we'll solve first this 4 comes plus, that means 2 cos 2x plus 2. 2 cos 2x could be written as 2 cos squared x minus 1 plus 2. It's going to be 4 cos squared x minus 2 plus 2. So that will be 4 cos squared x, that is v squared. So v is going to be square root of 2 cos x. That's the thing they asked to show. Careful, there could be careless mistakes like this earlier what I made. Okay, so what I did, A part question 5. Now B part, it says show that, they are saying that show that t is equal to half ln root 2 plus 1 when x equal pi by 4. So that's the thing we need to show. That means the time taken to move a distance of x equal pi by 4, the time taken is this much. So we know that when t equals 0, x equals 0, so we need to find how much, what will be the time elapsed, or how much will it take to complete a distance of pi by 4. Okay, so for that we need to get a relationship between distance and time. Already we got a relationship for speed v in terms of distance. In terms of distance means in cos x. We got the expression v equal 2 cos x. From that we can continue. V equal 2 cos x, we got it. So we know dx over dt. So v equal 2 cos x. V means dx over dt equal 2 cos x. So we need to integrate it. Integral of dx over cos x equal integral of dt. Okay, so what would be the limits there? So the limits are going to be when t equals 0, when t equals 0, x is equal to 0. When t equals t, we need to find where x equal pi by 4. That's a question, is it? Pi by 4, x equal pi by 4. Okay, so how to integrate 1 over cos x? We know that is sec x. Integral of sec x equal ln sec x plus tan x. That's given in the data booklet. So that's going to be integral of sec x dx. 1 over cos is sec x dx. That is limit 0 to pi by 4 is equal to 2 integral of dt. That is 0 to t. I already told the limit, right? So integration of sec x is ln sec x plus tan x. So that is ln, limits we can put, no problem, that modulus, sec x plus tan x, the limits from 0 to pi by 4, 0 to pi by 4 is equal to, we can put bracket, not modulus, anyway it's, we know it's first quarter, so 0 to pi by 4 is going to be 2t, limits that also 0 to. Okay, so we should substitute the values. So ln pi by 4 when you substitute, we will get sec of pi by 4. So ln sec pi by 4 plus tan pi by 4 minus ln sec 0 plus tan 0 is equal to 2t. Okay, sec pi by ln sec pi by 4. So you know that cos pi by 4 means 45 degree. Cos 45 is equal to cos pi by 4 equal 1 over root 2. So sec means 1 over cos. So 1 over cos means 1 over root 2. 1 over root 2 is equal to root 2. So sec pi by 4, that is sec pi by 4 means 1 over 1 over root 2, that is equal to root 2. So then we know tan pi by 4, that is tan 45 equal 1. So this is going to be ln root 2 plus 1 minus ln sec 0, that is 1 over cos 0. Cos 0 equal 1. So 1 over 1 is 1. So ln 1 minus tan 0 equal 0 equal to t. So that is ln root 2 plus 1 minus ln 1. ln 1 equal 0 equal to t. So t is going to be half ln root 2 plus 1. Okay, question 6. A particle P of mass 0.4 kilogram is attached to one end of a light elastic string of natural length 0.8 meter and modulus of elasticity 0.6. Other end to a string fixed to a point A on a rough horizontal table. Coefficient is given 1 over 7, the coefficient of friction. The particle P is projected from A with a speed 1.8 meter per second along the surface of the table after traveling 0.8 meter. That means the natural length of the string. From A, the particle passes through the point B on the table. Find the speed of P at the instant it passes through B. Okay, we'll put this on a diagram. It's better to put it on a diagram and write the data given. So we can say this is the particle which is attached to point A. We'll say this is the point A where the particle is attached and it's thrown from the point at a speed of 1.8 meter per second. So it's when t equals 0 we can take it. So when the particle passes through a point distance, that is a point B, the question is to find the speed at point B. So we need to find the speed at point B. Let it be V or V1 because the motion is continuing beyond that also. And at point B, the distance from A to B is 0.8 meters. So it attached to A by a string, so I should draw the string also. But when it reaches the point B, the string comes to the natural length. Until that, there is no other tensions. So beyond B only, there will be tension. The natural length also the same. So the data, if I write here, what are the data given? The natural length of the string is 0.8 meters. There is a friction, so the coefficient of friction is equal to 1 over 7. And the initial speed at A, that is 1.8 meter per second. Then also, yeah, that's all given in this. The modulus of elasticity lambda is equal to 0.6 mg, yeah, 0.6 Newton. Okay, so the first part, find the speed of P at the instant it passes the point B. So when it reaches the B, what's the speed? So during the motion from A to B, there is only one force acting, that is the friction. There is no other force. Tension won't be there because the string is slack. The length of the string is 0.8. The distance of B from the initial point is also 0.8. So until it just reaches the B, the string won't have any tension. So the only force acting on it is the friction. So I can use the A part, F equal mx double dot, or F equal ma I can use, x double dot doesn't matter. The force is opposing because the friction is acting opposite to the direction of motion. F equal mu r. The friction is F equal mu r. That's a friction force. But we know that friction Fr equal mu R. R is equal to weight because it's moving on a horizontal table. So when it is moving on a horizontal table, normal reaction is equal to weight because there is no vertical motion. So the vertical forces must be balanced. Upward direction, normal reaction R. Downwards weight, so R equal mg. So Fr is the friction acting on it. So minus Fr, that's the only force acting, equal m. X double dot, we'll find it because the constant friction, so we don't need any integration, we'll put it as x double dot, or even simple A I can use it, doesn't matter. Okay, so I'll put simple A, but don't get confused with amplitude in simple harmonic motion. So here this is nothing related to simple harmonic motion, so I'll use the standard equation F equal ma. A is the acceleration, right? So the friction is equal to minus mu r. I can write here Fr equal mu r. Okay, so minus mu is equal to 1 over 7, r is mg, r equal mg, that is mass of the particle is given as 0.5. How to write that? M is equal to 0.4 kilogram. So r equal mg, so 0.4 into 9.8 equals 0.4 into A. Okay, so find the A, so 0.4 will get cancelled. A is going to be 9.8 divided by 7, so A is going to be minus 1.4 meter per second squared. Okay, so that will be the acceleration, constant acceleration, because string is not yet extended, so the only force acting on it is the friction. So the part they asked to find the speed at B, that is the V1. I can use equations of motion for the motion from A to B. V squared equal U squared plus 2AS. I need to find the V squared, that I named it V1 squared equal U squared. We know the initial speed 1.8 squared plus 2 into acceleration is negative because it's a deceleration, minus 1.4. S is 0.8. So find the V1, solve it. So you will get 1 meter per second. Yeah. So the speed at B is 1 meter per second. Now we know the speed at B, that is 1 meter per second. We found it now. Okay, so B part, now they are saying the particle P comes to rest at point C on the table where ABC is a straight line. So it's moving further beyond B. So at the point B, from C, when it comes to the position C, the speed becomes 0. So I'll put the final speed 0. This is the point C. So beyond B, the elastic string will be extended. The extension, let it be x. So the extension, let it be x. Okay. So there, when it moves from B to C, the string will be extended. Yeah. So we are going to find x, I think. B part, find the total distance traveled by P as it moves directly from A to C. Okay, we need to find A to C, the distance. So it's not an issue. A to B we know 0.8. We need to find x, the extension. Okay, so x could be found in two different methods. First method, by using energy equations for the motion from B to C. It moves from B to C. What's the energy equation can we relate? Loss in kinetic energy, because when it moves from B to C, the speed is decreasing, means it's losing the kinetic energy. Loss in kinetic energy equal to work done against friction. Still it's moving on the table, so there is friction acting during the motion from B to C until it comes to 0, the speed, there is friction acting. So loss in kinetic energy equal work done against friction plus gain in elastic potential energy. We know the equation for the elastic potential energy given in the booklet, half lambda over L x squared. We can do that way and find the x. Okay, that is the first method. Second method, I can use again F equal m x double dot Newton's second law, and there I need to integrate and get it. So both methods I'll do it. Exactly the similar things all every time the paper, the questions are the similar approach. Only thing, situation slightly different, but the idea is the same. Okay, so B part, we'll start like this. B part, method 1. For the motion from B to C, I'm going to use energy equation. Loss in kinetic energy equal, I'll write it here, B part, I'll start here. Loss in kinetic energy equal gain in elastic potential energy plus work against friction. So due to work done against friction, sound heat comes. Yeah. Work done against friction means friction force into distance moved. Yeah. Okay, loss in kinetic energy. Loss in kinetic energy, initial kinetic energy, half mv1 squared minus half mv squared. V anyway 0. Gain in elastic potential, half lambda over L x squared. That's given the data book. Okay, so then work done against friction, Fr, the friction force into the distance moved from B to C, that is x. Okay, so that's going to be half into m is 0.4 into 1 squared minus, I don't need to substitute m because anyway v is 0, equal to half lambda we know 0.6 over natural length 0.8 x squared plus friction Fr equal mu r, Fr equal mu r, mu is given 1 over 7, Fr equal mu r, so 1 over 7 is the mu, r normal reaction is equal to mg, Fr equal mu r, if you want you can write it here, Fr equal mu r, that is 1 over 7, r equal mg, so m and r equal mg, that is m0.4 into 9.8. So 1 over 7 into 0.4 into 9.8 x. Okay, solve it. You will get 0.375 x squared. Rearrange it into the quadratic equation format. Yeah, 0. I'll step by step solve this one. You will get 0.2. Equal this, if you solve you will get 0.375 x squared plus this one will be 0.56x. So rearrange it into a quadratic equation, 0.375x squared plus 0.56x minus 0.2 equals 0. Solve it by using calculator in equation mode. You will get x equal 0.297, so I can say 0.30 meter, or x equal minus 1.79. Anyway, we don't consider extension as a negative value, extension is always positive. Therefore, distance AC, so A to C, the length A to C is equal to 0.8 meters plus 0.30 meter, that will be 1.10 meter. That's the answer. A to C. That's the question is about distance from A to C. So this is the first method. Second method, I am going to use F equal ma or F equal mx double dot, the Newton's second law. Okay, so the big part again, second method. The extension is measured from B, so in this direction, take that direction positive. So I'm going to use F equal mx double dot along the increasing x direction. Increasing extension direction is taken as positive. So what are the forces acting on it? If you think about the forces acting on the particle when it is moving towards left, friction, so minus mu r, that's a friction to the left, so minus, I'm taking towards right, positive, along the direction of increasing x. Better take that way, you won't make any mistake. So minus mu r, the friction is acting towards left, so minus. Then the tension is acting on it, so tension is equal to minus lambda over L x. These are the two forces acting on it in opposite direction to the motion, is equal to m dv over dt You know that dv over dt could be written as v dv over dx. Several times we came across. We'll substitute the values. So minus mu is equal to 1 over 7 r, you know that 0.4 into 9.8 rmg, minus lambda is 0.6 over length 0.8 x equal to m 0.4 v dv over dx. We'll write that way. Okay, so solve it for this. Okay, so this is going to be minus 0.56 minus 0.75x equal 0.4 v dv over dx. So we integrate it. So integral of we'll take the subject 0.4 v dv is equal to minus integral of 0.56 plus 0.75 x dx. Okay, so when x equals 0, the speed is 1 meter. X equals 0, careful limit, the speed is 1 meter per second. When x equals x, we need to find the extension. So x equals x or x equals symbol e we can put. When x equals e, the speed becomes 0. It comes to rest here, the question says. Okay, so solve it. So it's going to be 0.4 v squared by 2, 1 to 0 is equal to minus 0.56x plus 0.75 x squared by 2, limit 0 to x. Anyway, so when you put x, then a minus sign, you can change the limits, whatever it is. So it's going to be now, I'll continue here. Okay, so 0.2 v squared, 0.2 v squared, sorry, I mean 0.2 into 0 minus 1 is equal to minus 0.56 x plus 0.75 by 2, that is 0.375 x squared. When you put 0, both will become 0. So when you substitute the minus sign here, this will become 0.2. Is it 0.2 equal final equation 0.56x plus 0.375 x squared. Rearrange it into a quadratic equation format. 0.375 plus 0.56x minus 0.2 equals 0. Exactly the same equation we got in the first method also. Exactly the same equation, 0.3. So yes. So when you solve it by using calculator, you will get x is equal to either 0.30 meter, or the other one is a negative answer, we don't consider, minus 1.79. 1.79, yeah. We don't consider negative answer. So x is equal to 0.3 meters. So the distance of C, the extension is 0.3 meters. So distance of C from A, so A to C is equal to 0.8 meters, that is A to B, plus B to C, that is the extension 0.30 meter, that is 1.10 meter. Exactly the same answer, you will get it. Okay, C part of the same question. show that P remains at rest at C. Remains at rest means will it have a resultant force when it try to move towards B? We'll think about the forces acting on it. When it is at C, the forces acting on it, the weight and normal reaction, I don't need to consider, they'll balance each other. So already the string is extended, so that's the only force acting on it, this direction. That is the elastic, the tension, that is equal to Fe, or tension, I can say, the tension acting towards left. Okay, so other than that, if the particle try to move towards left, it has come to rest now. If it wants to move towards left, or if it has an intention of moving towards left, there will be friction that will oppose the motion that will be towards right. Okay, so if it wants to accelerate from rest if it wants to accelerate towards B, then tension must be greater than Fr, otherwise it can't accelerate from rest because it already has reached speed 0, or it has become rest. So if it wants to move towards B, the resultant force should be towards left, so the tension must be greater than Fr. Then only it will accelerate from rest to move towards B. So we'll find the tension first. So tension is equal to lambda over L into X. So lambda we know that 0.6 over L 0.8, X we know 0.3, we just now found it. So if you find that tension, that will become 0.23 Newton. Okay, if we try to move to the left, what could be the friction acting on it? Fr equal mu r, we already calculated several times. Mu is 1 over 7, mass 0.4, r equal mg into 9.8. So what could be the friction acting on it? That's a constant force, that is 0.56 Newton. So if we try to move towards left from rest, the required force should be towards left, the resultant force, but tension 0.23 Newton, so the tension is less than the friction, so it won't get a resultant force towards left, so it will remain at rest. It has reached rest. If it wants to move, it should accelerate. If it wants to accelerate, it needs a resultant force according to Newton's second law towards left, but it won't get a resultant force towards left because tension is smaller than friction, so it will remain at rest at point C. Okay, so this diagram is given, question number 7. A fixed points A and B are 7 meters apart on a smooth horizontal surface. A light elastic string has a natural length 2 meters and modulus of elasticity 4 Newton. One end of it, the string is attached to particle P of mass 2 kilogram, other end attached to A. So there is a string attached between P and A. So there the lambda 1 is equal to, for that string, L1 is equal to 2 meters and lambda 1 of it is equal to 4 Newton. Right. That is for the string AO. But it's anyway extended, but that's the natural length I put it. The mass of the particle 2 kilogram. We'll write the data separately. Another light elastic string has natural length 3 meters and modulus of elasticity 2 Newton. One end is attached to P and other end to B. So for this side, lambda L2, this natural length is 3 meters. 3 meters. And lambda 2, its modulus of elasticity is 2 Newton. Right. Okay. The particle P rests in equilibrium at O. So at O it's at rest, means resultant force acting on it must be equal to 0. Show that OA 2.5 meters. OA we don't know. We know the total length AB 7 meters. Each both rubbers have both elastic bands have extension. Because of the extension only, the total length has become 7. Otherwise this is 2 meters, this is 3, means it will add 3 plus 2 5. But total extension of the elastic cords, total extension will be equal to, this is 3 plus 2 5, 7 minus 5 2 meters. So that means if I take the extension of this is x1, this is x2, x1 plus x2, 2 meters. We'll use that also to find the A part. So they asked to find the OA, 2.5 meters. Okay, so to find OA, we know the natural length, but if I know the extension of this elastic string, then natural length plus extension of this, that is equal to OA. I can find it. So anyway, we'll write. So if I think about the forces acting on the particle, so the particle P is at rest. So there will be tension towards right T2, towards left T1. This is 0.4 kilogram. It's at rest. So we know T1, T2 how to write it. So T1 and T2 are balancing each other because it's at rest at O. So resultant force is 0. So we know that. So since it is at rest, T1 must be equal to T2. T1 must be equal to T2 because it's at rest. Okay, so T1 means lambda 1 over L1 x1 is equal to lambda 2 over L2 x2. x1, x2 are the extension of left string, and x2 is the extension of the right column, OB string. Right. Lambda 1 we know that 4 over L is 2, x1 is equal to that's equal to lambda 2, that is 2 over 3 x2. We'll solve it. So that's going to x1 equal 2 by 3 x2. So we can get a relationship between these two, that is x2 is equal to 3x1. x2, the extension of the second rubber, this one is equal to 3 times of the extension of the first one. But I already told that x1 plus x2, the total extension is equal to 2, because we know the actual length is 2 plus 3, 5, but the length is between A and B 7 meters. So x1 plus x2, if I continue here, x1 plus x2 is equal to 7 minus 2 plus 3. That is x1 plus x2 is equal to 2. Okay, so I need to find x1. They asked me to find the length of distance between A and O, means I need to find the extension of this thing, rubber, this elastic cord. Then that should be x1. So instead of x2, I can substitute 3x1. So that means x1 plus instead of x2, I can put 3x1 equal to 4x1 equal 2, means x1 equals 0.5. Therefore, AO equal its natural length 2 meters plus extension 0.5 meters, that is 2.5 meters. That's the first part. Okay, so what I answered is the A part. B part, the particle P now receives an impulse of magnitude 6 Newton second. Impulse means I equal delta mv, change in momentum. From that we can find the speed at which it leaves the equilibrium position. O is the equilibrium position because it's at rest. 6 Newton second in the direction of OB. So they are giving an impulse towards B from O. B part, first part, show that P initially moves with simple harmonic motion with center O. Okay, for that we need to get an equation or the expression, that is x double dot equal minus omega squared x format. That is, we need to get something like x double dot equal minus a constant, a number, into x. We need to get this equation format. Then only we can say x double dot is directly proportional to x in opposite direction minus sign. Okay, to show that, we'll see like this. During its motion, the particle P has shifted towards right. From here, it has gone to this position. So I'll draw here again. Particle has gone to this side, displacement x from the equilibrium position. So when it moved towards right from O, what will happen? Extension of the left elastic string will increase. It's already, already it has an extension. We found it 0.5 meters. Sorry, I think, yeah, we found that one 0.5 meters x1. already we got in the first part the x1 plus x2 x1 plus x2 equal 2, so we can find the extension of the second also. I'll do that. So we know the extension of the left string will increase by x, but the extension of right string will decrease by x because it's moving towards right. When the particle was at p, the extension x2, we can find the x2, we found it already. I got the equation in the previous part, x1 plus x2 equal 2 meters because 7 minus 5, 3 plus 2 5, so 7 minus 5 2. We found x1 is 0.5, so 0.5 plus x2 equals 2 meters. So the extension of the right side is 1.5 meters or 3 by 2 meters. So this extension will decrease by x, this extension will increase by x. By using it, we have to get the expression, this format. Okay, so when the particle P has shifted towards right, we know the x1, x2 values, right? So what are the forces acting on P that time? So this direction there is a tension T2, we'll put it as T2, this is T1. Now T2, T1 won't be same. Earlier when it was at the equilibrium position, T1, T2, they balanced each other. Now they won't balance because the extension of T1 has become greater than T2 because it's moved towards right. Extension of this one is increasing. Okay, so when we are writing this, we need to find the resultant force. Always we are going to use Newton's second law, F equal mx double dot. We always take along the direction of displacement. So the displacement is towards right. Along the direction of displacement, that is positive. So the extension of the right string will decrease by x, extension of left string will increase by x. Okay, so I'm going to write towards right, F equal mx double dot. What are the resultant force? Towards right T2, so T2 minus T1, because I'm taking towards right positive, so a force towards right is taken positive, T2, this is towards left, T1 equal mx double dot. Okay, so what is the T2? T2 is equal to lambda over L into extension, but the extension of T2 now, lambda 2 over L2. Now the extension, earlier x2 is equal to 1.5, now it's decreased by x 1.5 minus x minus T1, lambda 1 over L1. Earlier it had an extension x1 which is 0.5, now 0.5 plus x because the displacement is x towards right equal to mx double dot. We know the m, we can substitute m which is given as 0. The mass is given 2 kilogram. We can substitute that also. Okay, we'll solve it further. Now we'll solve that. Okay, so that's going to be lambda 2 L2, everything we'll substitute. So lambda 2 we know that 3 over L2, that is lambda 2 is 2 over 3, lambda 2 over L2, lambda 2 is 2, L2 is 3 into 1.5 minus x minus lambda 1, that is 4 over 2, L is 2, 0.5 plus x equal mx double dot. M is 0. The mass is given as 2 kilograms, so 2x double dot. Okay, we'll solve the left side. So 3 by 2, solve it. That is when you multiply 3, 3 divided by 3, 1 minus 2x by 3 minus, this is half, so 1 over 2 minus 1 minus 2x equal 2x double dot. I think I'm correct, yeah, check it. Yeah, it's going correct. 1 minus 1 get cancelled, minus 2 by 3x minus 2x, 6. So minus 8x over 3 equal 2x double dot. So that means x double dot equal minus 4 by 3 x. So that is omega squared, this is in the form of x double dot equal minus omega, this is the constant. So omega squared is equal to 4 by 3 and x double dot directly proportional to minus x. Therefore, it performs simple harmonic motion. Okay, so what I did is the B part first part. Now B part second part, what I did showing that it's following simple harmonic motion, I showed it. So remember the method, you take along the direction of displacement positive and according to that write the forces. So I took towards right positive, so the towards right is positive. So we take towards right positive is T2 minus T1 and follow it. We'll end up with the correct equation, the correct pattern will come. Okay, so we know the omega square, which is 4 by 3. Second part of B part says determine the amplitude of this simple harmonic motion. We know O is the equilibrium position, so it's going to perform simple harmonic motion. So during the simple harmonic motion, O is the equilibrium position. What is the equilibrium position? The position at which the resultant force is 0. So when the P was at O, the resultant force was 0, so that is the equilibrium position. So at the equilibrium position, we can find the speed because we know the impulse given to it. So we know the speed given to the particle at the equilibrium position. So we'll find the speed of the particle at the equilibrium position. We can find it. So that is the B part, second part. So we know that impulse is equal to mv minus mu. So the impulse given, so B part, second part, that is second part, B part. Okay, so we know the impulse given to the particle, that is 6 equal. So immediately after the impulse is applied, the speed is v. So the mass is 2 times v. Before that it was at rest. So the speed at which it's going to move away from the equilibrium position, that is v, is going to be 3 meter per second. The question is determine the amplitude of the oscillation. So we know the equation v squared equal omega squared into a squared minus x squared. You know the x is the displacement always measured from the equilibrium position. So when x equals 0, so you know the maximum speed occurs when x equals 0. That is at the equilibrium position. So x equals 0, we know the speed which is 3 meter per second. That's the maximum speed. So when x equals 0, speed is at the equilibrium position. We know that. We found it 3. So 3 equal omega squared, we found it here 4 by 3. A squared we need to find minus 0. Find the A. Solve it and find the A. So it's going to be 9 by times 3 squared. Right, v squared, v is 3 meter per second, v squared 3 squared. So from this A is going to be 3 squared 9, 9 into 3 27 over 4 square root. So that's going to be, we can see 3 root 3 by 2. So that is 2.6 meters. So that's the amplitude. Amplitude equal 2.60 meter. Okay, so that's the B part, second part. Now C part, find the speed of P as it passes. Now they are saying, sorry, there's a statement, the point C lies on OB, point C lies on OB. As P passes through C, the string attached to B, the right string, becomes slack. Find the speed of P as it passes through C. Okay, so when it passes through a point C, when it passes through point C, they are saying there's a point that is C. When it passes through point C, the string attached to B becomes slack. That means the extension of the right side string, extension of the string becomes 0. That's the reason it's getting slack. So the extension of the string right side, we found it, x2, already we found it, that thing 1.5 meter, we already found it. x2 is equal to 1.5 meters. So that means the displacement of the particle when the string slacks, this displacement is equal to 1.5 meters because the string is getting slack. The right side string is getting slack means the extension of the right string becoming 0 means we know already that extension is 1.5 meters. So the displacement from the equilibrium position is 1.5 meter. The question is find the speed of the particle. So we can use the equation again, the same equation. So that is C part. So you can tell it as statement. So C part, when the string PB becomes slack, X equal to 1.5 meters towards right. Right, so that means V squared equal omega squared A squared minus X squared. We need to find the V. Omega we know that is omega squared 4 by 3. A squared we found it, that is A squared that is 27 by 4. Is it A squared, that is 27 by 4 if you square it, 27 by 4 minus X squared, that is 1.5 means 3 by 2, 3 by 2 squared, 3 by 2 is 1.5, 3 by 2 squared equal 9 squared, that is 9 over 4. So solve it for V. Anyway, that's not an issue. You will get 2.45 meter per second. Okay, so the last part of this question, find the time taken for P to travel directly from O to C. O is the equilibrium position. O to C, how long it takes. So we have two equations related to displacement and time, but you must know where to use which equation. So that B, there are two equations we use. One is x equal A sine omega t. Other one is x equal A cos omega t. Okay, where do we use this equation sine omega t format? If the particle initially, that means when t equals 0, if the particle is at the equilibrium position, when you substitute t equals 0, sine 0 equals 0, x equals 0. So initially if the particle is at equilibrium position, then to find the displacement later at time t, we use x equal A sine omega t. When you substitute t equals 0 here, you will get x equal A, that is amplitude. That means initially, if the particle is already at the extreme position, maximum displacement position, and if you want to find the displacement later at time t, use this one, x equal A cos omega t. Okay, but here we know that initially the particle was at the equilibrium position, it was thrown by applying impulse from O. So initially when t equals 0, it was at O. So when t equals 0, it was at O means we had to use this equation. So initially it was at the equilibrium position. We need to find the time when x becomes, the displacement becomes 1.5 meters. That's the question. It's asking to find the time taken to move from O to C. We know the distance C, which is 1.5 meters. So substitute here 1.5 equal amplitude. We know that we found it already 2.6 sine. You have to use your calculator in radian mode. Sine omega, we know that omega squared, we know that 4 by 3. Omega, that should be 2 over root 3. 2 over root 3 is the omega into t. Okay, take sine inverse, and you know how to solve. Divide this by 2.60, take sine inverse, but careful, calculator should be in radian mode. You will get t is equal to 0.53 seconds. Okay, so that's all this paper. I'll discuss other papers also. You can pass your comments how this mechanics, you know, why I discuss the reason mechanics is actually physics. All the physics principles are used in mechanics, mathematics, but the only difference is in physics the questions are related to numerical values, but in mechanics the questions are with variables. But the principles what we use in physics and mechanics exactly the same. So you can solve or you can handle the questions in mechanics if you are familiar with physics principles. Otherwise you might go wrong.